Okay, so today we are going to cover section 3. Today is going to be relating transformations and congruence. Now, you've probably seen these transformations in middle school. And what a transformation is when we move in a plane, we're going to move or change our figure to produce a new figure. When we have a rigid motion, that is going to be a transformation that is going to preserve length, angle measure, and area. So in other words, our figure is going to have exactly the same size and same shape. It's going to stay congruent. So the transformations we're talking about, our figures are going to stay congruent. So it's going to be exactly the same size and shape. It's going to stay congruent to itself. Another term for these transformations is called isometry. Okay? In our book, we're calling them transformations in rigid motion, but in other books, it might be isometry. Now, the types of transformations we're going to talk about, we're going to be sliding them. So a slide, it could be a flip, or it could be a turn. And we're going to see official words for these on the next slide. So the key concept here is congruent figures and transformations. Two figures are congruent if and only if one or more rigid motions. Now, we can do two different movements. We can slide and flip, or we could slide and turn. So we can do more than one rigid motion. But when we do these, it can be used to move one figure onto the other. If any combination of translations, reflections, and rotations can be used to move one shape onto another, then the figures are congruent. So the first one, notice the arrow is like straight. This is a slide. It's pointing to how it slid. Notice in the word's translation, I've got the letters SL right there in the middle. That's your slide. For the middle one, the reflection, notice in the middle of the word here, we got the words FL, so that's going to be like your flip. And then for the word rotation, it's got two T's, so I'm going to say that's like a turn. Notice this little arc type thing. When we rotate things, we're like rotating around a point in a circle. And again, you can move your figure and use more than one rigid motion. Again, you could slide it and then flip it, or you can flip and slide, any combinations of any of these movements. On the next slide, we want to know what's happening in figure A. What happened from the blue picture to the red picture? What kind of transformation? Yes? That would be a rotation. Notice this little like curved arrow here, this arc. This is telling us that they are turning it. So this is a rotation. Now in figure B here, we've got two different things happening. What is happening from the blue triangle to the green triangle? What happened to it? Good. He just told me both. So from blue to green, they slid it, so that's a translation. And then from green to red, they flipped it, so that's a reflection. Know these three types of transformations. This will be the type of question you will get on the quiz.
You'll get it wrong if you say slide, flip, or...
So memorize these three official words, translation, reflection, rotation, and know what they mean. Okay, so here it says, explain why figure A and figure B are not congruent using transformations. Now, if you look at it, it looks like it was a slide and a flip. However, when we do the slide and flip, Notice that blue quadrilateral is not going to match up perfectly. Notice this side here looks like it's a little bit longer than this side. Now, on the quiz, if you need a ruler, I'll give you one to borrow. You can always use your ID to measure things, but you can see that it's not going to line up perfectly. In order for the transformation to work, it has to be exact. Exact same size, exact same shape. Okay, so I'm going to go ahead and graph the 3 ordered pairs, and then we're going to apply this rule that's here to each of the ordered pairs. So what they want us to do is to the x coordinate, we're going to subtract 2. To the y coordinate of each one, we're going to add 1. And this is going to give us our transformation. But let me go ahead and graph the original ones. I'm going to graph them all in blue first. All right, so here are the 3 original order pairs. Now to get my new order pairs, I'm going to take the first one, the -4, 3. To the x, I'm subtracting 2. So my new coordinate will be -6. To the y of the order pair, I'm going to add 1. So my new order pair is going to be -6, 4. So it's up here. Then I'm going to do the same thing to the order pair 1, 4. To the x, I subtract 2. So I get -1. To the y, I add 1. It's up here. And then to the last order pair, do the same rule. Subtract 2. I get 0. Add 1 to the y, and I get -4. And here, if I connect them, notice that the 2 triangles are exactly the same size and shape. However, what happened, it was a translation. I slid it 2 units to the left and 1 unit up. So whenever they give you a rule like this, x, y, and then an arrow, and then if they show that you're going to be adding or subtracting something to the coordinates, this is always going to be a translation. When we add or subtract to the x, that will move our figure left and right. So when it's a -2, this would be a shift to the left, 2 units. Over here for the y, this tells me up and down. And because it's +1, this would be 1 unit up. So they shifted all of the original points 2 units to the left and 1 unit up. This transformation is a rigid motion and it's a translation. We slid the figure. And it did stay congruent, so yes, it is a rigid motion. The rule that's here isn't a formula. This rule is just whatever they gave you. So just as soon as you see that you're adding or subtracting something to your coordinates, that should be recognized that it's a translation.